Recording. Hello. Those of you joining us from home. All right. We're going to go through two examples today. First one is up here. This looks like it has potential, but it's not the exact model of what we've been working with. What can we do? We're not going to cry.
That's kind of specific.
However, can we use U substitution? That is always what we should look at. Oh, it looks like we could complete the square. Okay, U substitution, not going to be helpful because U, we would have to make 4x minus x squared. Okay, we have x squared in the numerator. It's not going to be helpful. But it looks like maybe if we complete the square, maybe we'll have something to work with. Okay, so let's do that. So, first of all, when we complete the square, what does the leading coefficient have to be? A positive what?
1.
Okay, so I'm going to take this right here, negative x squared plus 4x, and we need to factor out that negative 1 so we can complete the square. Now, what number completes our square?
4.
Okay, we can't just add a number to an expression. We have to balance it out. So we have to subtract what number?
No, we have to add 4.
We have to subtract a negative 4 because technically that's what we added. Okay, so this becomes negative x minus 2 squared plus 4. Let's come back to our integral. We can now write it like this. I see a squared minus u squared.
Use a sign. 2 sine theta.
Okay. Since we have a number squared minus something with an x squared, right? We can use our sign trig substitution. Okay. So now this is like 2 squared minus x minus 2 squared. Okay. Since x minus 2 is what is being squared, then x minus 2 needs to equal the a sine theta.
Oh.
Interesting, right?
Yes.
Which means dx is 2 cosine theta. D theta. Huh?
So the x theta would just come to x equals 2 sine
Okay, and just since we're here, let's go ahead and draw a triangle. Our sine ratio opposite over hypotenuse is x minus 2 over 2, right? If we divide the 2 over, we'll have that ratio, okay? And then radical 4 minus x minus 2 squared is our adjacent side. All right, ready for some fun?
I'm always presenting my questions.
Okay. X squared. Well, x is technically 2 sine theta plus 2. Do you agree? So we have to plug in 2 sine theta plus 2 quantity squared. Over 4 minus x minus 2 is the same thing as 2 sine theta. So I'm just going to write 4 sine squared theta right there. Okay. And then dx becomes 2 cosine of theta. What's wrong?
We're not legally.
Well,
Just like
we know that this is 4 times 1 minus sine squared, right?
4 times cosine.
So it's the same thing as 4 times cosine squared. Okay, we're getting good enough at these where we can probably go from there to in our head.
The denominator will
cosine.
eliminate each other. The denominator will eliminate with the original dx.
Some of you are going to have some vision and see that that's going to happen, but I would still like to see this step, and I'd like to see you physically cancel those out. Now, what must we do?
Well, you've got to FOIL and then separate.
We need to multiply that binomial squared out. So we cancel, that makes it nice because we no longer have a fraction, but what we do have is 4 sine squared theta plus 8 sine theta plus 4. Okay. Anytime a sine squared appears in your integral, how must you change it?
Use the power.
Okay, changing this to 1 minus cosine squared is just going to get us in the same trouble as what we're in right now. And so the power reducing formula is going to be our only option. Okay, remember for sine squared it is 1/2 minus 1/2 cosine of 2 theta. Okay. So let's do some combining of like terms here. So technically we have 4 times 1/2, and then we're going to add that to 4, which makes
6.
what?
Nothing.
We have 4 times negative 1/2 cosine of 2 theta. And finally, we can take the answer.
Wait, where'd you get the 6 again?
4 times 1/2 is 2, and then we add it to 4.
Oh.
Just making it easier on ourselves here. What?
We had actual simple addition. That's why I was able to answer.
John, antiderivative of negative 2 cosine of 2 theta.
Negative 2 sine theta? Or negative 2 sine 2 theta? Okay, yeah.
Do you agree with them or no?
Yes.
Okay. So negative sine 2 theta.
Agreeing with Kathy is always the best.
Bailey, antiderivative for 8 sine theta.
Negative 8 cos theta.
Can you explain to me why it's negative?
Sine positive.
Wait, what are you asking?
I'm asking you for the antiderivative of 8 sine theta. And you're telling me negative 8 cosine theta. Okay. You good with that? Have some confidence here, Lenny.
You're being like
You're
Mr.
right.
Marks.
No,
It's like,
you just like tell me that it's wrong.
it's like Mr.
No, I
Marks.
didn't tell you that's wrong. I said, can you tell me why it's negative? And you couldn't tell me why it's negative.
Well, I told you it was negative in the first place, so
And
obviously I knew
can
why.
you tell me why?
Because the derivative of cosine is negative sine.
Okay, that's what I wanted you to tell me.
Okay.
Oh, it's not that you're wrong. I wanted you to defend your answer.
You
give
don't
us
have any
Martian answer,
confidence
it's
in
like,
here, you
sure.
can't do that to me.
You sure that's your
Are
answer?
you sure of that?
You're
Okay.
sure you want to answer?
Josh in, antiderivative 6.
Okay, so I'll start again. Let's see.
Never did I say it, David, you're wrong. Just wanted you to defend your answer. All right. Now, our triangle is in terms of theta. A couple of you encountered a problem where this happened, okay? 2 theta is not okay. And so, I reminded you of the double angle formula for sine. What was it? Sine of 2 theta is?
Does that work for cosine too?
We have a different double angle formula for cosine, but we won't need it because the only time we are using the, anytime we'll have the angle of 2 theta is because we use the power reducing formula, and both power reducing formulas are in terms of cosine. So we'll always be taking the antiderivative of cosine to get sine.
What was that one?
This is the double, that was a double angle.
Nice.
Okay. All right, so now we just have to switch our answers back to x. Sine of theta, what is that ratio? Excellent. Cosine of theta, what is that ratio?
Square root of 4 minus the quantity x minus 2 squared over 2.
Good. So then we have minus 8 times that same cosine ratio. Okay. And then we have theta. Anytime we have theta, I want you to go back to the, I want you to use the trig function that we defined x to be. So since we defined x minus 2 to be 2 sine theta, that means x minus 2 over 2 is sine theta. And so theta is the inverse sine of x minus 2 over 2. You can reduce that, but I'm okay if you do not. Right? This is AP Calc, so you don't have to reduce. Well, I mean, it really wouldn't be that bad.
I would just be a lot of extra work.
Really, the only reducing I would not necessarily expect, but I'm okay with you doing is like 8 divided by 2 is 4, negative 2, cancels out with this 2, and then that would be the only reducing I would. I just did the fine fractions.
You would know where you got theta.
Yeah, so anytime we have theta, we go back up to what we defined x to be, all right? So here, x minus 2 equals 2 sine of theta. So I got sine of theta by itself. And then if we want just theta by itself, then we take the inverse of both sides. So the inverse sine of x minus 2 over 2 equals theta. Other questions? Those 3 identities, power reducing for sine, power reducing for cosine, and then the double angle for sine, you will need to know those 3 for the quiz on Wednesday, and then of course the test whenever that happens. Okay?
Yes.
Okay. One more example. This time we have limits of integration.
Wait a second. So could you make? I mean, could we just do the same thing we've always been doing, just at the end, we have to integrate it from there to there?
That is an option, but it's not our only option.
Is it easier now?
Well, let's just first set up the trig substitution. If that's what we're going to do. Obviously it is. But we cannot use u substitution because if u is x squared plus 9, then du would be 2x, and we have x cubed of that. Okay? So, since we have that handy dandy x squared plus 3 squared, it is going to be very easy to use trig substitution using which trig function.
A tangent over 3 times tan theta.
So we can let x equal 3 tangent theta, which means dx is what? Okay, now, was it Bailey that asked, can we just do everything we did and then plug in 3, plug in 0? That was Josh, sorry.
Like,
Somebody,
once we finish fixing it, we're gonna make it ready to integrate. We integrate it and then evaluate it from 0 to 3.
that is an option. A quicker option, if we have limits of integration, we can avoid changing back to x if we change our limits of integration to in terms of theta. So just like we had that option with like u substitution, change your limits in terms of u, we can change our limits of integration to be theta instead of x. Okay, so how do we do that? So if x equals 0, we have 0 equals 3 tangent of theta.
Which means tan theta must equal 1 over square root of 2. Or theta must equal 1 over square.
No. Which means tangent of theta equals 0. When is tangent of theta equal to 0?
No, same thing for y equals 0.
So we'll stick with the first one, theta 0. Okay. Well, we'll just go to the first, like if we rotate from 0, go to the first one that it hits as you rotate. Okay. If x equals 3, then 3 equals 3 tangent theta, which means 1 equals tangent of theta.
That's one over square root of 2.
We need the angle, which is pi over 4. Cosine and sine are radical 2 over 2.
Yeah.
Okay, we want the angle.
Okay.
Okay. All right, so what we can do is as we do our trig substitution, we can just change our limits to 0 to pi over 4, and now everything is in terms of theta. We don't have to use our triangle to switch things back. This it might just take out a couple steps at the end, okay? So let's do our substituting here. X cubed over Is everyone okay with the substitution that I just made? Excellent. So we know that we're going to be able to factor out a 9 from this. And what is tangent squared plus 1 the same as? Okay. So our denominator becomes 3 secant theta. Do you agree with that? Now what? So these 3's cancel, and this secant cancels out with one of these, right? So we have 27 tangent cubed theta secant theta d theta. Now what? How do we take the antiderivative of that?
We can split it into tangent squared theta times secant theta tangent theta.
Okay, we can't let u equal, well, first of all, we don't have an antiderivative for that. If u is tangent, du is secant squared, so that's not going to work. So our only option is to split this to be tangent times tangent squared times secant. And change the tangent squared to 1 plus secant squared.
At this point, can you just move the 27 outside?
Yes, of course. So let's do that. Okay, so I went ahead and distributed the secant times tangent into the 1 plus secant squared. So we have tangent secant and then plus tangent secant cubed. What's the antiderivative of tangent secant? Okay, then over here, we can let u equal secant theta, which means du is secant theta tangent theta d theta. And so this is essentially u squared du. Okay, we've done simple u substitution enough that we know that this is going to become 1/3 secant cubed theta. So now, what's nice is instead of having to change these back to our x's, we can just plug in pi over 4 and plug in 0 and get our valuation. So, let's do it. Ready? So we have 27 times. First, let's plug in pi over 4. Secant of pi over 4. Plus 1/3 of square root of 2 cubed. So 2 radical 2. Right? 2 cubed is 8. Radical 8, 2 radical 2. What's the secant of 0? So we have 1 plus. Okay. So we have
Why isn't secant of pi over 2 divided by the square root
it if you reduce it, like if you rationalize it, you would have to rationalize 2 over radical 2. You get radical 2. Easier way to write it. Okay? So help me out. Do we have 5/3 radical 2 minus 4/3? Which means what do we have?
35 over 3 times square root 2 plus square root of 3.
Could we just say 45 radical 2?
36.
Okay. That's not tangent squared, is it?
That is, wait.
So we have this means secant squared minus 1. We got all the way through the problem before anybody noticed that. Okay, all that's going to change.
I did that right my notes.
All that's going to change is that what's going to be negative. This is going to be negative. Don't, no, it's just changing a sign. It's going to be okay. Are you following me?
Yeah.
I couldn't figure out why I
Yeah.
was 25 square root of 2 minus 8.
Yeah.
So this is,
I've been trying to do it on my own.
so what that's going to fix is that is going, this is, so -3 plus 2 negative radical -1 plus 1/3. Okay, does that look better? Yeah. Is that better?
Part of my problem is kind of just how far the link is, so I have to,
Secant squared minus 1. But then it came to plus 2 plus calc.
Oh. Okay.
So I was trying to figure out what I'm
Yeah. Okay, this should be better. Sorry about that. But nobody else stopped me either, so we're all to blame. Okay. What I want you to do, well, you guys don't have books in front of you. So I just want to point something out. And I think you encountered this a little bit in your homework already anyway. But like number 15 was 1 over 1 plus x squared dx. Okay? It doesn't have to be the square root of 1 plus x squared. Like 1 plus x squared could be raised to any power, and you can still use trig substitution here. Okay? So you can still use tangent for your trig substitution here. If you look at number 30, this is one that you're going to do today. X squared plus 5 is being raised to the 3/2 power. Okay? You can still use tangent trig substitution here.
I didn't even.
Wait, number 30 is not one that I'm assigning you. Just kidding.
is tangent the only one you can do this for?
No. I'm trying to find other examples. Like number 42. One minus t squared is to the 5/2 power. 1 minus t squared, we know we can use sine substitution for that. Yep.
For those questions, it just said to use x equals tangent theta. So I just went ahead and plugged it in without even considering the fact that it was squared and not square root.
Okay, and that's why I wanted to point it out. It is okay that a squared plus u squared is not under a square root. Do you see what I mean?
Yeah, but it could be under anything. What about one? Can it be just one? I mean, obviously there would be easier ways to solve it. If it was just 1 plus x squared to the first power, but.
Yeah, that's just our tangent, but yeah, you could.
Oh.
But you could use trig substitution.
Yes.
In 42, you do have that under a square root. It's just then, so could it be like, grab it and cubed, or to the
And
cube
then
root, and still do
and
substitution?
then you do substitution.
I mean, technically, cube root wouldn't be really nice because that wouldn't really help with like the sine square or the cosine square that you're going to get. You know what I mean? It's going to have to be an even root power, or it's going to have to be a square root of some kind. But I guess my point is it's okay if it's like raised to the 3rd power, right? There you go. That is the end of today. So your goal sheet has your homework. Tomorrow we'll get a review.